viaje por el mundo, aprendizaje apasionado con STES Rocketry, ¿no? Ellos son un equipo, organización interdisciplinaria dirigida por estudiantes dedicados a desarrollar talentos de ingeniería a través del diseño, construcción, pruebas y exhibición de sistemas de cohetes complejos propulsados por motores de cohetes de alta potencia. Su objetivo es convertir a sus miembros en ingenieros talentosos, proporcionándoles las habilidades y herramientas necesarias para crecer y tener éxito. Todos los días aspiran a lograr hazañas que solo se creían posibles en la industria mediante la incorporación de revisiones de diseño profesionales, pruebas rigurosas y documentación detallada de sistemas hardware, software e individuales, ¿no? Ahora, bueno, paso a la presentación en inglés. So this is the presentation for STES Rocketry, no? Their title of presentation is Journey Across the Globe, Passion the Learning with STES Rocketry. So they are an interdisciplinary student-run organization dedicated to developing engineering talents through design, construction, testing, and showcasing of complex rocket systems powered by high-power rocket engines. Their goal is to develop their members into talented engineers by providing them with the necessary skills and tools to grow and succeed. Every day, they aim to accomplish feats only thought possible in industry by incorporating professional design reviews, rigorous testings, and in-depth documentation of individual systems, hardware, and software. So they are now in the Zoom. So good morning to Anish, Prashant. Can you introduce yourself individually, please?
Good morning, everyone. It's a pleasure to be here. Can you hear us?
Yeah, we can hear you.
Okay, that's good if you are loud and clear. So I'm Ganesh. I'm from India, and we all are in Pune currently. Pune is situated in Maharashtra, India. Next to Mumbai. It's next to Mumbai. And we are representing today a team, STES Rocketry, and we are proud to be here, to be among friends, to be among people we have met and made bonds with. And today we would like to tell about our journey more and share as much as we can. Thank you.
Pretty nice, Ganesh.
Hello guys, so my name is Swayam. I handle the payload subsystem. So the project 𝐕𝐼 and the dead reckoning subsystem, we have developed that across the years, and also the muon detection and all the payloads that we have developed until now, we are going to represent that.
Hello, my name is Atharva. I am the head of the business development department, and I look after the media, the communication, the business development of our team, the marketing of our products, and the operations. Hello.
Hi guys, this is Prashant Patil. I am the team leader of this Rocketry, and also I will look for the systems engineering and also the propulsion systems.
Nice to meet you all, and it's a pleasure to have you all here in this event. So would you like to present your PPT presentation, or I will do that? How would you accommodate?
I checked the share screen option, but I think it's disabled by the host. So if you would present it, that would be better.
Okay. I will give you the co-host so you can share your screen. Let me. Oops. Yes. Okay. So now you have the co-host.
Okay, thank you.
Thank you.
Okay, so
Yeah.
hello everyone. It's Test Rocketry, and we are proud to be here once again. Thanks for having us here and letting us represent our country. And without wasting more time, we'll just get into what today's whole thing is about.
So as I mentioned in the beginning, this will be a question and answer, an interview. So I will start
Yes.
with the questions. And the first question
Okay.
is mostly an introduction to STES Rocketry. So can you provide a brief overview of STES Rocketry and its mission and objectives?
I would like my team leader to introduce our team.
So our team started back in 2017, and since 2017, our team have participated in Latin American Space Challenge as well as the Spaceport America Cup. Our team have represented in these two events for like 5 times, 4 times on-site and 1 time virtual, 2022 LASC. So the mission of our team was to like build the sounding rockets more with the innovation at its peak. Like the people in my team are way much sounder in technical knowledge to let them enhance their technical skills. And yeah, when
Okay, so the real thing of all this team is about is to make engineers more efficient and learn new things. So when we started it out, even in India, like India is pretty known for its aerostructure and aeronautical things, but to be honest, when we went to our parents and were like, we want to build a rocket, we didn't get that support which we hoped for. And I think somewhere every child thinks or imagines to make something innovative and creative, but sometimes a society thinks it's not possible for a small person to do it. When you see big government companies investing billions of dollars in this industry, thinking to make a rocket on your own sounds impossible. But the team is all about changing that perception and trying to create something within ourselves and trying to create an impact to reach beyond these expectations of the society. So that is what the team is about, and for which we are dedicated, and will try our best to expand the STEM culture among engineering students and as well as other people out there, whether it may be children or anyone who just is keen to learn this. I'm sorry, Proberto. I think your mic is on mute.
Yeah, thank you for that. I was saying that it was really nice. Actually, your team is like, as you say, a team that can build these rockets in a low-cost budget, no? And so, and that means that everyone can build it, no?
Yes.
That was really nice. Well, the next question is about what the rocket development and the competition that you are being on. So tell us about the rockets the team have developed and the competition you have participated in. What are the key challenges you faced, and how did you overcome them?
Okay, so we have participated in majorly 2 competitions, that is Spaceport America Cup and Latin American Space Challenge. So as you might know, we all met at the Latin American Space Challenge held in Sao Paulo, Brazil. And other than that, we also participate in the Spaceport America Cup, which is held in America, New Mexico. And we have made at least 4 projects by now. That the first one was for SSC. It was named APJ after our late president and also our inspiration for making rockets, Dr. APJ Abdul Kalam. He's pretty famous for Indian innovation, and hence that was the inspiration to start the team itself, because we have heard stories of him when he was a child. He used to make different rockets, and somehow they made it into a big international rocketry domain named ISRO now. And ISRO is all around the world now. We can say that proudly after our various achievements, whether it may be Mangalyaan for Mars or the moon landing, which happened recently. So yeah, that was it. that was the inspiration for our first project. And from that, we carried that spirit to the Latin American Space Challenge for last 3 years. Unfortunately, we didn't compete it in SSC for last 3 years because we had some issues with the visas. But now that's all done. We are planning to set our feet in American soil soon.
Okay, and yes, as a follow-up question, how many rockets did you develop? So how many versions do you have?
The team has developed around 4 rockets. And if we are also including prototypes, then that goes for 5. And currently we are developing 2 more. So yeah, that total gives a count of 7, I guess. Yeah.
Wow, 7 rockets. That's a really big number for just 3 years, you mentioned, that you have participated.
Yeah, 4 years.
4
last
years.
3 years because we had a hit of Corona as well. So that's
Yeah,
called a
the
lot of
COVID.
progress.
Yeah, Coronas.
Yeah.
You're right. Well, and yes, next question is for STEM education for children. So you mentioned that you mentioned the inspiration for the creation of the team, but what exactly inspired you to start these workshops for children, and what are some of the most memorable experience that you have while teaching rocketry and payload to young minds?
So, an inspiration to conduct these workshops. So it was that so in India there is a lack of awareness about amateur rocketry or rocketry chosen as a field for pursuing higher studies. So when we started, so we started from from school students. They were from standard 5, 6, 7, 8, 9, 10. And so the name of the workshop was Rocketry 101, which meant that we will be teaching them the introduction part of the basics of rocketry, the physics principles, and the basics of space science, and also create a fascination about astronomy because it's much more visually appealing to them. So, so we started with the workshop. The first workshop was very successful. We got a good response. About 50 students participated in the workshop, and the younger group, which is the 5th, 6th, 7th standard, 5th, 6th, 7th classes group, we taught them with various techniques like the balloons. We used to blow the balloon and like leave them, and it showed it showed the Newton's third law of motion. So these kind of topics or these kind of ideas, they weren't introduced to them. It's usually taught in the 8, 9, 10 standard. So they were fascinated with the practical experience. We also conducted a few tests that we conduct, and we showed it to them, like the ejection test or the grain burning test, the propulsion test. So when they saw it, it created a fascination, and many of them are taking interest. They ask us questions, doubts related to rocketry, and we have a WhatsApp group. It's kind of a community where we share updates about our team, then the latest developments in Indian Space Research Organization. Also, we have a club called Astronomic Club, which shares these astronomical information about the astronomical events on this community or this group. So many students are benefiting from it.
Okay. And how did you contact these schools or these kids? I mean, they are from maybe a link school from your university, or just like you contact direct from the director or any professor?
So what we did was, the school we conducted it in is actually connected to university itself. So that wasn't a problem. But that's not the end, actually. We actually communicated with more schools that include some of the schools like Podar International here. I'm not aware if it's there as well, but yeah, there are some international schools as well we collaborated with. And they were pretty interested when we pitched it out to them. So basically, we reached out to educate these children about it, because there was a lot of fascinating cases last time. Like after a workshop, people used to make their own small rockets and test them out with simple avionics boards. And that was pretty fascinating for us. Hence, we kept moving in that direction. And in that way, we thought we are contributing to the STEM culture for what the team is actually made for, right? So we kept doing it again and again. We kept pursuing it, kept meeting people, kept making connections, and somehow, somewhere, we found a way to meet these people.
Hey, that's nice. That's really nice. So you can you expand more your the schools that you can reach and the kids that you can reach in all your STEM activities. Well, the next questions are more related with your projects, not your project's highlights. No, so we are going to start with the first questions. That is, dive into the details of your projects. No, let's start with your project Levy. No, the acoustic levitator. What is its purpose, and how did you come up with the idea?
Our basic purpose was, firstly, we started developing the project. We had the purpose of levitating objects in midair. Like it would be easy for space transportation as well. So we started developing it from December last year until June this year. So in between the development, we started like changing the problem statements of our project to from levitating the objects midair, we gained our problem statement to, it was like Chitrath. It
was more like we shifted it towards the study itself.
Yeah.
So we observed that if we are to levitate something right now in the rocket, it wouldn't create much impact, because it would levitate such a tiny thing that it wouldn't make any sense to just use that implication. Instead, what we thought was to research this idea first, and if it goes well, then we'll create a bigger prototype for something to levitate properly. Right now, we have the test data of what we conducted in the LAC 2023 this year. And from that, we are pretty happy that we can estimate how big that grain must be to be levitated in the rocket itself and to be cushioned from the rocket's thrust, because the rocket applies a lot of impulsive thrust. So it's a lot to be contracted by the levitation system itself. So the technicalities are still in progress. So that's why we don't have the exact size right now, because it's to be published in a research paper soon. But other than that, I think you'll hear about it soon.
Yeah, we basically started its mathematical model. Like we had a formula in which we used some constraints. So we like changed the geometry of the shell, the efficiency of the shell, the levitator changes accordingly to that. So we had a first problem statement that is levitating some objects. Then we shifted our statement to Doppler effect, like verifying the Doppler effect in our rocket itself. When our launch vehicle reaches the max speed or comparable to max speeds, the frequency shifts, like the nodes which are created in between the shell, the levitator shell, shifts downwards or upwards, considering the frequency and the velocity of the launch vehicle. So we wanted to verify this data, which we had predicted earlier. So that's what our problem statement was. About the idea, how we got that, it was
okay. So about it, to simplify all the things, it was more like we were watching a clip of a UFO. So what the UFO does is use tracer beams, right? Like it's a ray of light and things just go like levitating upwards. And we were very fascinated from that fact that is it the technology of future? Can we replicate it? And we start digging into it. And we found that you can levitate things other than electromagnetic things by sound. We were so fascinated that we started some prototypes and projects. And then we found out that, yes, you can shift this node, which will create a sudden shift in height. In that sense, you can actually do the UFO levitation with sound, which was pretty cool for us. And that was the main inspiration for the project itself.
Okay, so basically you were curious to recreate that UFO thing. So that was nice.
Yes.
And about the payload itself, so you mentioned that it will be really difficult because of the velocity and the impulsion of the rocket to
Yes.
maintain that in the center, right? And it's in
Yes.
continuous progress, I think, your work.
Yes.
Okay, that's cool. Could you explain the next project that is called
Yeah.
Rocketry? No, the GPS alternative using gyro sensors. What is its
Yeah.
potential applications?
Its application. So we have heard that our Indian Space Research Organization has been using similar techniques for tracing the rocket trajectory when they launch their satellites and all. So it is nearly 99% accurate, and many more space agencies across the world are currently using similar sensors or similar technologies like the dead reckoning.
So to be more specific, the truth is when you cross the Karman line, things go start getting very shifty, because when you are using the GPS and you cross the Karman line, suddenly GPS signals might get lost. So GPS is not that accurate or not that reliable in such cases if you are using a proper rocket which is going into the space. For such things, you need proper calculations. Other than this, you might have heard that SpaceX had made those self-running rockets, right? So that too is actually a derivative of dead reckoning, because that uses different kind of gyroscopes. So it was our first step towards that end goal.
Dead reckoning is basically a navigational term, ancient navigational term. Like in ancient times, ships were using dead reckoning. Similar to dead reckoning, it was not that advanced like it's now. So carbon filtering, it's a mathematical derivation which is used to reduce the noise which we get from the rocket. So as you know, the GPS starts getting noise when the rocket reaches its maximum peak velocity. So we use what we get, we trace the last coordinates of our GPS which we get from that, and use it with sensor fusion with the gyroscopic sensors, and get precise or nearly precise trajectory for the rocket, or we estimate what its path should be. So that's basically a dead reckoning. It was used in Midnight Sun, which was our project last year. It was used in the 2022 Latin American Space Challenge last year in Brazil.
And all this process, all this mathematical operation occurs in the microprocessor in the rocket or in the station that is on Earth?
Yes, because we are not using a lot of high data right now, and we are just trying to replicate the dead reckoning itself in a small case scenario. It wasn't that much of a problem to calculate all this, because the gyroscopic sensors we were using were doing half the work already. They were already giving us pretty precise coordinates, and hence we just had to compute it live on laptops here on the ground. So we made it possible that way.
Okay, so that's nice. Now we are going to the next project, that is your ongoing project, the Leo Therapy Cleaner CubeSat. So what motivated you to work on this? What are your goals for it?
So the Leo satellite is all about cleaning our low Earth orbit. That's why we named it Leo, low Earth orbit, right? So the thing about it is we are rocketers, and we expect everyone to be shooting a rocket in few years. We are here to motivate everyone to do that. But how can they do that if the whole orbit is a mess of debris, right? there are many microscopic debris which will actually directly shatter your rocket into pieces when it reaches that line. And it was a huge problem for which there is no current solution. And with increasing time and increasing launches, it's just going to grow. So for an economical advantage and giving this new generation a chance to launch something into the air, LEO is in current projection. But it's more about cleaning itself through various means, making it as efficient as possible using Earth's gravity to do so. Like we are trying to rotate it in the orbit like this. So what we want to do is use this center of momentum as the momentum for letting the debris go out of the orbit or inside the Earth's surface, depending on the size of that debris. If it's too small, we can just send it inside the Earth's surface because then it will melt away and won't cause any harm. And otherwise, we'll shoot it outward. And with the proper balance, you can always keep it rotating in space because there's almost no drag. So with proper management, you can clear a lot of debris very efficiently in a very efficient way for the environment. And hence the LEO is being developed. Sorry, Prabhupada, your mic is mute.
Yeah, sorry again. Well, as you mentioned, there is debris. This space debris is like actually space junk, no? Space pollution. And it's really nice that this project wants to clean all of this. No, that principles are in Earth orbit. They are not useful. They're actually junk. If this project really can grow and launch, it will be like the first sustainable project that its goal is to clean this Earth orbit.
It's a very ambitious project for us, and we have kept our fingers crossed. And we are trying to contact some big space agencies to launch it because we cannot launch anything into LEO ourselves. So it's under development. I hope it gets into the orbit and starts at work soon.
Yeah, and we will do it. It's a really great project, and I know that especially because of your country have done many space news these weeks. I know that most of the people, because when people are interested and show interest in these projects, then all the business are interested too. So it's great for those. And lastly, about the moon detector sounds intriguing. And what exactly is it and how does it work?
So for its inspiration, I'd like to mention one of favorite YouTubers known as Veritasium. I think everyone might know him because he's quite popular in the science community. So he actually inspired us to investigate about these phenomena called muons. So he had a video in which he explained how muons, which are bombarded from the space, can actually cause bit flips on your laptops or on your computer systems, which are here on the ground. And the chance of getting a bit flip increases how far you go up. So naturally, when we are launching something to the space, we are thinking to contribute to this research as well. So muon detector was actually based on an MIT-based project, and I think it was called Cosmic Watch, from which we actually took inspiration and started building this project. So it was all about calculating how many muons there are in the atmosphere where we are launching. So that in future, when we have this data, we'll try to make redundant computation systems such that no bit flips occur or no sudden casualties occur among the rocketry community. Because rocketry is pretty unsafe if a sudden blip is to be happened and a sudden boom is to be happened. So for that, it's pretty necessary. Even if there's a slight chance, we have to take care of it. We have to ensure that it doesn't happen, for which we needed those data, and hence we had the inspiration and motivation to make the muon detector.
Yeah, I remember that that new that of the space watch that you mentioned, that
Yeah,
it was goes like, so you can buy it, and it was like $100 like it. But yeah,
yeah,
it was really nice if you can replicate it. Well, you're inspired of of this space watch, no, and cosmic watch, no, so to develop your
yeah.
project. Okay. Well, now we are going to talk about your future plans, especially with the team. No, what are your future plans for SES Rocketry? Are there any upcoming competitions that you're excited about?
Mm, so for our vision, I'd like to address it first before we mention the competitions we are participating in. So it's all about creating this ecosystem where we can motivate people, right? So we are not stopping here. We will reach out more schools this year. We'll try to make new projects. We'll try to research more and try to make new friends. That's, I think, one of the most important things when you are in this community where there are a lot of great minds, innovative minds in the field of rocketry and payloads, and for which you need great communication, great bonding, for which you have to meet those people. Hence, the competition is the thing. We compete not to prove anything, but to go there, make new friends, meet more people, talk about the STEM culture, and learn ourselves. That's the main motto. If we win, that's a big yay. But that's not the real motivation for doing all this. It's all about pushing ourselves. So we'll always keep pushing ourselves. That's the future. When we'll go, we'll make sure that our juniors are ready to pick our roles and lead the way. That's something we are aspiring to right now. And about what kind of competitions we are going to participate in next, Prashant will address those.
So we are planning for the SSC 2024, as well as that we are planning to launch our rocket in LSC. But primarily we are working on the SSC and hope so we get a chance to fly our rocket in the Europe, that's European rocketry competition. If we get a chance to fly there, we will definitely go for the Europe. And yeah, that's pretty much.
So you are going to compete in 4 competitions, actually.
3 competitions actually.
3 competitions. Okay,
Yeah.
yeah. That's really nice. And one thing that you mentioned about your vision, that's I think that most competitions, it's correct that they have now their first prize, second prize, but their objective also is to make of these teams to push themselves to start working in their own team, and also have that contact network, to all the countries that participate in that competition. As we did it in the LAC 23
Yeah.
this year. Yeah. Okay. Now for the next questions, we are going to talk about the impact on the students. How your activities and projects influence the students who have been part of the STES Rocketry, or your members. Have you seen any transformative experience of career aspirations sparked by your initiatives?
So one of the objectives of our team is to make efficient engineers or good quality engineers. So a good quality engineer means that he or she, they can work with students or members from all the departments across all the disciplines. Like we have students from computer science, electronics and telecommunication, mechanical engineering and chemical engineering. And we all work together under the same roof. Then second thing is we look after the technical as well as the non-technical aspects of the team. The technical aspects include the testing and the research and the studies for the rocket, and the non-technical aspect includes looking for permissions, taking grants, also the communication part, communication with the team, communication with the sponsors, looking for sponsorships, working for the media and the marketing of our team. So, so a member in the STES Rocketry team gets exposure to all these things, and it results in their overall development. Also, when we conducted workshops, uh, uh, everyone of us got a chance to express ourselves as teachers, and that way we could imagine that how we could uh, make the complex ideas or complex topics and explain it in an easier manner. So that way we work together, and there are also many other things that Chitraj would like to say.
So about this, to tell you practically what the change in these people are. So if there's a new recruit, at first they are like, we cannot do it. How is it made? How are these things done? How are these hardware worked upon? That's the initial approach of everyone. But within a month or so, if you visit the workshop, you will find them working with every kind of sensor, with everything, with every kind of protocol. And we are not spoon feeding anyone here. They are keen to learn. They just ask us question and keep doing their thing. And that in turn creates an engineer who wants to solve problems, right? The only things that an engineer is actually concerned about here is to solve problems, to find a problem and to give a solution. How you do it is none of our concern, but the way you do it will always be appreciated. That's the change we have seen in people here, and we have learned in these few years, because we have experienced that engineering is all about managing everything at once. I think everyone can relate with that. Everything is important, whether it may be a lecture, whether it may be a date with your friend, it doesn't matter. Everything is important, and as much as important. Even though you have some set priorities, you have to manage everything. And we have seen everyone learn that in this team. With time, in at the start of this team, many people are congested and they have a lot of things in mind, a lot of luggage to carry. But when they communicate, when they start solving things, they realize that it's not that hard and anything is achievable if a proper way is found.
Yeah, I share that thought that in a team and as an engineering, you can the communication is really important, because maybe you can want to do all by yourself, but you have a team. You have a team with experience, that can help you with those first steps that maybe will be difficult for you, but with a proper lead, could be an easier work. Well,
Yes.
now for our last questions. What advice would you give to young individuals interested in pursuing a career or hobby in rocketry or STEM fields?
Okay, so I think for this one, we'll individually say one thing. So as an advice for what we have learned. So what I think, what was the most valuable lesson for me was is to not wait, is to start creating. If we are waiting for something to be done, to be executed, we'll always keep waiting. If we are like, oh, I don't have this technology right now, let me wait, I'll do it after 2 years. Let me write it down somewhere, then I'll work on it later. No, you never work on it later. If you want to work on it, you have to work on it right now. Try to build things. Even if it's very lame, try to make it. Then you'll know what impact it has. Things change with time. Maybe initially your idea is not that good, but when you work upon it, you'll find something useful. Like Levi is an example of that. We started it as just being fascinated by it, and later we realized it's a great project about which we can research about. And another thing that I have learned is the Indian, what do you say? The Indian way of jugaad. right? Okay. So the jugaad is a term we use for doing things or solving things in the budget you have with the things you have. Even if it's very low budget, you have to do it, and it doesn't matter how weird it looks, how weird it sounds, we have to do it. So for that, we do the Indian jugaad. So I think when I came in Brazil, I actually discussed it with a lot of people there, and I found that that spirit is actually among all the engineers. Whatever they have, they try to use it at its fullest and try to make the most of it. And that's the biggest engineering spirit that I can see all around the globe and in everyone's eyes, which is the one of the best advice, which was also given by my senior, to use these skills, even if it might sound ridiculous, just make it and then test it out. Don't be like, oh, it sounds ridiculous. It's just so funny. For example, like when I started my rocketry journey, we had some shortage with nichrome wires, right? So here we get a scrubber, which we dishwasher scrubber, right? So it is actually just to wash out rough stains. But later we realized this wire and the nichrome wire is the same thing, but sold in a different packaging. So we brought a bunch of them, cut them up, and started using them, and it worked flawlessly. So that's the spirit of jugaad. So you try to find those things around you and try to make the most out of all those things you have. That's my best advice to start creating and make use of everything you have around you.
So, the advice that I have for an aspiring rocketeer or anyone who has interest in sciences, keep observing. So, the thing with us is that most of us are busy with our phones, and most of us are occupied with our phones, the social media, when we go out, when we are out in the public, or when we are out in the nature. So what happens is we we don't observe the problems that people face or the problems around us in our surroundings. So if we don't know what the problems are, we will not look for a solution. We will not be curious about the things going on around us. So I think it's very important that we be in the present moment every time and observe the things around us. Yes, using internet and social media and other things is very helpful for us to connect and carry out such events and be like enhance our knowledge. But if we are present in our environment and we look and observe other people, then we will find more problems and we will get their solutions. So that's my advice.
So, as my colleague Chitra said, we are like keen to getting things done in our limited resources, right? That's jugaad thing. Okay. So my advice would be like, you should not stop doing things. If I get it done with an example, so since I have joined, I had like many projects. I started with the load cell, the propulsion electronics. Okay, so it was like difficult to calibrate the load cell. It was like mind blown and everything. I'm thinking like, what should I do? What should I do? Had plenty of tests with that, and nothing is doing as we expected. So things are just like we have to find things. It gets resolved in the end, but we should not stop in between. Like while doing the Levi project Levi, we had plenty of tests around, and as far as I remember, the initial 2 or 3 months, the subject which we are gonna levitating was not levitating in between. So we were doing like, we are testing around, doing some calculations, changing the geometries every day, like thinking about it. We are doing everything we can, and finally the payload started working as we expected. So things aren't like easily as we expect them to be. So we just have to stick around it. That will be my advice. Shant.
My advice would be like, don't wait for someone to push you. Just be curious about things. And you don't need all of your stuff we have right now to build your rockets. You can actually build your rockets in softwares. You can test them out in softwares, and then you can just ask someone who have that kind of resources to help you with. And the most important part that we learned here very hard way was that don't rely on the calculations. Just don't rely on them entirely. Test everything with have a proper safety with you to test any of the system you have. That's all.
Okay, thank you all. Those were a really precious advice for all the people that are here. Actually, in Peru, there are not many teams for Rocketry. Okay, but I hope that maybe this presentation can give them an opportunity to keep pushing it to build all the rockets that they want. Thank you.
It's our thanks for letting us have a stage here. And we are sure hoping to see more Rocketry teams pop up to compete with, to share knowledge with, to collaborate with. And it would be an honor again to meet you next year as well. And it was an honor to be here with you guys to present about our country, about ourselves, about what we do. And a really big thanks for having us here. And a good afternoon as well. I think it's afternoon there right now.
It's 12.
Yeah, it's nearly 12. So good afternoon and adios to all the people in Peru.
Okay, actually, before you go, there are some questions in the chat. Yeah. So
Sure.
we will start with Steve Anthony. He says that, or he asked about what kind of material do you usually use to build these rockets?
Okay. I think Prashant can answer that. What kind of material do you use?
Yeah, okay. So sorry for the noise.
Yeah, sorry for the noise there.
Sorry for the noise. They're at the workshop right now.
I'll let them know. Just a second.
So going for with the aerostructure, the aerodynamics, the outer fuselage, we use the fiberglass because it's gives us pretty much equal strength as the carbon fiber, not equal, but almost like 85% of what we get from the carbon fiber. Along with that, we can also transmit our radio signals from our rocket to the ground station system we have on our Earth or on the ground level, you would say. Yeah, for the aerostructure we use that, and all of the machining part are done on the aluminum 6061 because it's pretty much lighter, and also it gives us the yield strength of 38,000 psi at the highest temperature, like 400 degrees Celsius till 400 degrees Celsius. So yeah, it's good for us to go with the aluminum 6061. And for along with that, what other material we use?
PLA?
Huh?
PLA, ABS.
Yeah, for all the 3D printing part, we use PLA and ABS because it's readily available. Another thing is PLA is pretty much lighter and stronger. That's why we use PLA other than PETG. Yeah.
Okay. So now we're gonna translate specifically those materials for our audience. So, bueno, ellos dijeron de que usan sobre todo fibra de vidrio, no fibra de carbono, ya que les da un mayor porcentaje de protección, además de que pueden tener su telemetría es mejor, no hay tanta interferencia, además que usan el aluminio y también el PLA para unas impresiones. Okay, now with the next questions, they are asking about, in the field of engineering, which area should we focus on most? For example, mechatronics, robotics, biomedical engineering, mechanical engineering, electronic engineering.
I think it's a mix of mechanical and electronic engineering. It's neither of those perfectly. It's both of them. So mostly it's mechanical engineering because you have to work with the aerodynamics and the structures, that's a major thing, right? So when you say a rocket, you make it a rocket using structures. So the structures is all based on mechanical engineering itself. But when we are to be discussed with the working of the rocket, then we have things like chemical engineering popping up, and then mechatronics and biomedical. These all stuff might pop in the payload subsystems or the thing you are actually sending inside the rocket. So that's where these parts are actually contributing to.
Basically, all these subsystems are all these like disciplines are the extension of mechanical engineering, which we should focus the most.
Yes.
Okay, but actually all projects are multidisciplinary, interdisciplinary, so
Yes.
it's like you can use all engineers. Bueno, ellas comentan que mayormente se usaría la ingeniería mecánica como la ingeniería electrónica, mayormente la mecánica debido a la estructura, los motores que se usan, ¿no? Y la parte de robótica, biomédica y mecatrónica, o en la parte del payload, es decir, la misión que va dentro del cohete. Okay, now with the next questions that asks Jairo Solano. So, what are the feeling about the recent landing in the moon as a country as India, and how start your passion for this special sector? What advices do you give again for those that want to have this career for the space in our country, for example?
About the moon landing, it's always an honor, because when we were in Brazil, so when we were in the competition, that thing happened, right? So when we were meeting people there locally, they were greeting us and congratulating us on it. So it was a very, very great experience, because it was such an easy way to communicate with everyone there. They were just congratulating us, and we felt so special. And in that way, we felt that the whole thing was very heartwarming, and it felt like home, because we were being appreciated for what we do. And I think everyone wants that appreciation from while to while to keep their horses going. Other than that, the inspiration itself, as I've mentioned, it was Sir APJ Abdul Kalam, to be more specific, for most of the team. And other than that, it was that question in our minds that can we make a rocket? That was a big thing. Other than that, the advice have already been given by 4 of us on an individual level. So yeah.
Okay. So I'm gonna translate. Bueno, ellos se sintieron muy, muy agradecidos, porque justo la noticia pasó cuando yo estaba en el concurso en Brasil, en el 𝐈𝐍𝐃 que mencionaron de este año, y la mayoría de gente con que los conocía, pues los felicitaban y se sentían de verdad muy, muy bienvenidos, muy especiales, ¿no? Y mencionan que su pasión prácticamente se surgió de una pregunta, ¿no? ¿Podemos hacer un cohete? Y todo empezó desde ahí, desde esa pregunta, y empezaron con todos lo que han explicado en esta ponencia. Y respecto a los consejos, ¿no? A los consejos, dijeron que lo mencionaron antes, ¿no? Que sería que nunca dejes de esforzarte, atrévete a todo, ¿no? Siempre busca solución a los problemas y no esperes a que alguien más te impulse a que lo hagas, ¿no? Okay. For the next questions, they are asking about what computing systems have been used to support your telemetry.
Okay, so there are 2 parts of it. One is the RF module and then the microprocessor itself. So to get more deeper into the RF module stuff, we are using ZigBees, and this year we are actually shifting to LoRa. So as you might know, LoRa are the long range transmitting modules, which use a lot less power and give us a lot longer range. They generally try to use lower frequencies as well. So that's one thing. And other than that, ZigBees are also the other way around. In a recent project, we tried to use ZigBees because they have a faster data rate of that data transfer rate. Hence, we were using ZigBees, and that's pretty much it for the telemetry.
Okay. Actually, I work with LoRa, not with 6B, but it's true that the data rate of LoRa is really low. But it's like it's like a price that you pay for have that long range. Ok. Bueno, traduciendo la respuesta, la parte del módulo de radiofrecuencia principalmente usan la tecnología Zigbee y LoRa, ¿no? Están interesados en mejorar la parte de LoRa ya que tiene un alto rango, ¿no? Pero en los proyectos de este año y los anteriores han usado Zigbee debido a que tiene un alto porcentaje de envío de datos, es decir, se envía más rápido, en otras palabras. Ok. For the next question, they ask, do you believe it's possible to develop a rocket using plant-based materials to make it less polluting? Or should only conventional materials be used? In Mexico, an interpreter is investing in plant-based materials to make satellites less polluting.
So it's funny that this question actually came up because last year we were actually trying to experiment already on this thing. So we also had got a research paper related to the plant-based materials and their composites. So it is definitely possible. We have seen a lot of such composites which are reliable and can be used in future. We are right now lacking with the strength itself, which is not a big difference and can be covered up like soon if we invest more into the materials, what kind of materials we should use and what kind of plants should we use with what kind of mixers. Like, do you like for the composites we use something like a resin right now, right? So that makes the stuff hard. Like, such things need to be invested on more to be exactly scalable, but for sure it's possible. We have seen a lot of such research paper and we have heard about working with bamboos or pineapples. There's a lot of stuff we have heard about plant-based material. I think Swayam and Prashant can tell you more about it.
Like actually there is one research paper for one of our team members. So what we made was a plant-based like composite from the pineapple's fiber. Do you know the leaves of the pineapple? Yeah, so we made a sheet type fiberglass sheet kind of. We have fiberglass sheets, right? Similar kind of sheet we tried to make with that. And we tried to make a composite out of it. So fiber tube like structure from it, which we can use for the rocketry. And yeah, we didn't work pretty much well, but it was kind of fulfilling our goals. But yeah, we are still researching on it and probably make it possible to launch a rocket with it soon.
Okay, that's really nice. I didn't know about that. It's six or it's being researching the plant-based materials, but would be a really
it's currently in research and developing part of the team. It's just for the future goals.
Ok, bueno, para responder a esta pregunta mencionan de que sí es posible y que ellos mismos han leído papers y ellos mismos están haciendo una investigación. Uno de los papers que mencionan es un material a base de las hojas de manzana, ¿no? Que han podido crear un material muy parecido a la resistencia y composición de la fibra de vidrio. Entonces, bueno, ellos no, o sea, han leído un paper que han hecho tal conversión y que es muy importante que se siga la investigación ya que es necesario tener ese porcentaje cuando tú mezclas materiales, ¿no? Okay. Now for the last questions, they ask if you could please share a publicity available on internet. I mean, like all your media, Instagram, Facebook, maybe so these people can reach to you. No, they can contact you because I know that most here in the audience there are like members of a team that want to build a rocket, but they don't know how to start. And maybe you can help them.
About that, please feel free anytime to contact us, and we are always here to help and to share our knowledge as well. So that's not an issue. Any kind of question we are welcome to answer. Other than that, about the links, I'll just stop screen sharing and share you the links in the chat itself Just give me a second.
टास्क भेजा व्हाट्सएप पे जा टास्क ये एक स्टेस रॉकेटरी की है अभी सी हर्बर्ट
So I have shared our team's website. Let me share the other websites as well. I have with me.
कॉलेज की ये ले
Nisha?
कुछ भी कॉलेज की दे भाई और बस टीम भेज दे भाई डिस्कॉर्ड दे दे डिस्कॉर्ड मेरे पास नहीं
Here, the other is for college's website. And
डिस्कॉर्ड इंस्टा के
I'm sharing the Insta contact as well. Please feel free to message us about any queries you have. We'll be glad to answer it.
शेयर
So on Insta is it's as Test Rocketry Team. I'll share the link as well. But you can search it on the Insta search page as well. You can even look into my account. It has the name. So this is the Instagram for Stress Rocketry. Just a second. We'll try to share a Discord as well.
you should see something अरे इसमें भी खोल के जाना है ये 5 खोलो ये हाँ मैं उसका तो उसमें मैं पेश हो गई इसमें
Hmm?
Okay.
Okay, so this is the invitation link for our Discord's channel. It would actually stop being used in 7 days, so try to be quick about it. But yeah, mostly people here would join immediately if they had to join, so that wouldn't be an issue, I guess. And other than that, we are pretty active in on the Discord community. So any question raised there would be answered pretty soon, I guess. So yeah, thank you.
ये 4 एड्रेस करो
Thank you. Bueno, chicos, por favor, únanse al link de Discord si desean. Está solo activo por 7 días, ¿vale? Para su información. Así que si es que desean poder también ahí ver noticias de los chicos, adelante. Okay, well, those were all the questions that our audience made you for you. For our organization, the IEEE ASS Uni, no, in Peru. It was a really pleasure to have you all in this event, no, the World Space Week of 2023. We will look for have you in the next year too, and meeting you again in maybe the next competition, one of the 3 that you mentioned. Okay, it was really nice. It was a really nice presentation for me and for all the audience. Thank you so much for taking this time.
And thank you for having us here. It was a pleasure to meet you again through this online platform and sharing as much as we can. I hope we would have motivated someone so that we can see more Rocketry teams next year from Peru itself. And we'll be glad to meet you again next year, and we'll try to be in contact so that we can collaborate something as well. Let's hope we do. Thank you.
And for one last thing, we can take a picture, okay? But I
Yeah.
wanna invite all the audience to turn on their cameras, okay? Por favor, chicos, vamos a empezar vamos a tomar nuestra foto respectiva con nuestros amigos de la India. Por favor, si pueden ir poniendo sus cámaras para la respectiva foto. Esta la vamos a estar compartiendo en el grupo, ¿vale? En el que todos se han unido. Así que les invitamos, por favor, que prendan su cámara. Vamos a darles unos minutos. Ok.
उसको देखिएगा
Okay. So we're gonna take the picture in 3, 2, 1, and okay. Take the picture. Again, thank you for your time. I know that I don't know what time is it there. I think it's really late.
No, it's not that late. It's near to 10:45 right now.
45 in the night.
And we'll like to also take a picture
Okay,
with
okay,
you
yeah.
With
guys.
you guys.
Okay, I guess that's done. And thanks
you.
for having us here again. It was a pleasure and it's an honor to represent India for Peru. Thank you.